telescope, just a snapshot. Look at that comet tail. Is that not incredible? These are called magnetic resonance lines of the comets. This is not real common, but it's not rare either. But one this big is certainly a very, very rare event. Now looking at that, and if you were somebody 500 years ago, would you not be a little bit frightened? If this thing just showed up one morning and you walked out in your backyard and you saw purple eggs laying in your hen house and this thing was in the sky, yeah, I think you would put two and two together too. Magnetic resonance lines are caused by the sun. As the comet gets real close to the sun, it's passing through the magnetic field of the sun. The sun has magnetic loops based on the activity that it's having at any given time. You've got magnetic fields that skip one, yeah. This activity, these solar outbursts, create magnetic fields. The loops that you see in this picture are closed magnetic fields. They have a north and a south pole. Open magnetic fields don't come back and create a bipolar situation. They just simply dissipate into space. And as the comet passes through the open magnetic field, it creates those striations that you saw in Comet McNaughton's tail. Nothing really fancy, and it goes away very quickly. And then we have irregular tails, and these are caused simply because of solar activity. If the sun is very active and it's having a lot of eruptions, the little comet tail is just going to have to take the brunt of it. And then comets ultimately die, and we see comet catastrophes, some closer than we would like to. This is a remarkable picture of Comet 73P breaking up a few years ago. Look at all the pieces coming off this comet. Now this may not mean a whole lot to you, looking at this picture, but let me tell you what, if mankind has anything to fear, this is one of the things we need to really be thinking about right here. One of its sister comets, this is a less than a 24-hour picture of a major explosion in this comet, upper left to lower right, a close-up taken through Hubble. Look at the changes in 24 hours. The thing literally exploded. Now what comes out of there that we are going to be exposed to depends on how close that comet may be at any given time, or what I study, is the Earth going to pass through that debris field? Are we eventually going to go around the sun, and at some point in the future, is the Earth going to go right through that debris field and get bombarded by stuff that we didn't even see coming because it happened 200 years ago? And it's one of those unknowns, literally unknowns. On Mars, you can see right here, or you did at one point, this is an escarpment on Mars. We were looking at one on the moon at the Star Party out at the pavilion last night. On the moon shows these things. Mars has plenty of them. These are comet scars. These are places where comets have impacted at an oblique angle and scarred the planet. And this actually is very, very recent. You can simply tell by looking at the fact there's no very little secondary cratering inside of this large plane of debris. Now all that leads to this particular event right here. Some of you remember this. Back in 1994, we had a comet called Schumacher-Levy that broke apart. And this is an actual photograph. It's a composite, but this is actually this expanse of it. This, in other words, it was put together because the actual field of view was so huge. This thing broke apart. It was a good comet to begin with. But then all of a sudden one morning, it just broke apart, just shattered. And this is what it left. Every one of those is a separate comet now. Every single one of them. The problem is every one of them is still in the same orbit. They all still have mass, and this was a very massive comet, and it was headed towards something. It was headed toward the largest planet in the solar system, Jupiter. And this was one of the most remarkable things that any of us have ever had an opportunity to witness. This thing, one at a time, the comet's direction, as you can see, was going this way. Jupiter was trying to get out of its way, going this way. And as it did, the two just, by fate, the timing was terrible for Jupiter. Perfect for us to watch it. But these things slammed into it one after another. And as Jupiter rotated, which it rotates 9 hours and 55 minutes for one complete rotation of an object that's 11 times larger than Earth. As Jupiter was rotating, this thing was like somebody shooting bullets at a moving target. And it scarred it as it went around. This is an actual picture, a Hubble picture of Jupiter being bombarded with these objects from that particular comet, Schumacher-Levy. Each one of these, you can trace the path as to where it hit. Now, that may not seem too drastic to you. That's Jupiter. what the heck, man, Jupiter's way out there, it's 500 million miles away. I'm on Earth, I'm content, my government takes care of me. And then you look at a picture of Jupiter compared to the Earth. This is actual size, okay? Now, can you remember how big those explosions were on Jupiter? Does it ring a bell? Here's Earth, here's Jupiter. Now look at the size of those explosions on Jupiter. What do you think would have happened to the Earth if one of those had hit us?
Gone.
Just one. That thing was absolutely flying through space. And it had 17 particles that hit Jupiter. I mean, these are the kind of things that people think, oh, it's never going to happen in my lifetime. This was 1995. Most people didn't even know it happened. In 1908, it happened on Earth, but we were lucky because this was a little one. A lot of speculation as far as what Tunguska was. This was in Siberia. The object that hit exploded above ground. We don't know what it was, but the likelihood is it was either a piece of a small comet or it was a small comet, period. We think probably a piece, and there's good evidence as to why we believe that. Oh gosh, this is after I keep hitting with my wrong finger. 3/100ths of a second before the actual entry, the light. No, there were no witnesses, by the way. No one lived through this. There were some reindeer that survived, but they couldn't talk. This thing, 3/100ths of a second, we speculate the sky probably just lit up, brighter than hydrogen, probably hydrogen blast equivalency. 1 second after it actually entered the atmosphere, not the Earth, 1 second, it exploded above the ground, 6 miles above the ground. This is obviously artist rendition. I really doubt that there was an old log cabin in Siberia, but that artist took some liberties here. And in 3 seconds after the entry, and entry again into the atmosphere, either 6 miles up, somewhere in that area, everything was instantly incinerated, not from the comet, but from the shock wave. The concussion wave, it's like if I had a box of valuable glass, depression glass, and I wanted to break it really easy, the easiest thing for me to do would be to drop it right here off the stage and let it hit the floor. And let the concussion of the drop shatter the glass. It would shatter everything in the box because one piece would shatter another and so forth. The concussive effect of this hitting the atmosphere caused a shock wave that instantly incinerated the ground. The heat was definitely there. We know for a fact, based on recent studies, that the ground was incinerated. As a matter of fact, sterilized. Nothing at Tunguska will grow even today. A force of 14,000 mile per hour winds devastated the landscape for over 200 miles. All of these things, you can read those yourself. But this is an actual photograph that it took them 7 years to get in here to find out what had happened. And this is back before the days of accurate seismographs. Everyone knew, ship captains, for example, in Alaska, ship captains in San Francisco Bay watched their compasses that floated at that time, watched them move. They knew that there had been an earthquake somewhere. And there were waves, tidal waves, small ones, but there were nonetheless tidal waves. People realized this had happened. But to hit it with this force and at 14,000 mile per hour winds, this thing had to have a lot of power. And it never even reached the ground. Comets, if they don't hit us, and if they don't dissipate, everything in nature, everything in the universe, one of the things I like about astronomy is everything recycles. It's a perfect recycling bin. The comets eventually will disintegrate like the ones that I showed you just a minute ago. They break apart into pieces, and those pieces become our light shows. We have meteor showers because comets do disintegrate. So we get a little bit of added benefit from them. Some of these meteors hit the ground. This was a very active meteor shower here. This is actually a wide-angle shot. Those of you familiar with the sky, that's Orion, the belt and the sword right up there in the upper right. So you can see that's a wide field of view. That is a 30-second picture. So you can see just how incredible. That's taken from the Rocky Mountains. You can see how many meteors per second there were during that meteor display. Nothing special, nothing magic about the meteor showers. For example, here's the path of Halley's Comet we talked about. The Earth going around the sun encounters the cloud, the debris, remember the dust trail, twice a year. We go through it in May, and that's our Eta Aquarid meteor showers. We swing on around and pass through it again in October. We're in it right now. and that's the Orion meteor shower. So there's nothing magical about a meteor shower. It just happens to be the Earth passing through a debris field, a cloud in the wake of Halley's Comet. So when you see those meteors, it's kind of fun to realize that used to be Halley's Comet. Maybe my grandfather saw the comet with those pieces still intact. Another comet shower is the Perseids, which is a very active one in August, and it's the remnants of Comet Swift-Tuttle. And I brought a little thing with me here. This particular thing may or may not be the actual remnant of the only comet impact that we know of on the planet. And it came from Argentina. And it's a very famous meteorite field, and it's the only field that we think may be the result of an impact like you saw in Tunguska that took place above ground and showered the ground with tens of thousands of meteorites. I'll show you, we've got one up here on the stage. I'll show you, and everybody can touch one a little bit later on. So let's talk about ISON real quick. From November through December, you're going to have quite a show, we think, and I don't think anything's changed in that regard. We don't really know what to expect, but we do have some better indications tonight than I had this morning. So the information's still coming in, but there's some very promising information that does suggest that what you see very well could look just like this. It may actually, in December skies, maybe a week before Christmas, this may be something that you're actually going to see, very similar to this. In July, we picked the comet back up. All the way until May of this year, we were following it at the observatory, and it did not change any. It plateaued. It was at a certain brightness and stayed there. It was not brightening as it got closer. Wasn't getting any bigger. The tail wasn't getting any longer, and everybody was beginning to go, man, this thing's just not going to work out. It's not going to be the same comet. It got too close to the sun to see for several months, and on July 4th, Hubble picked it back up again, and it was the same. It still was 15th magnitude, had that little short stubby tail. Nothing had changed with the comet at all. That's the actual comet on July 4th. But today, here's where the comet is. Back then, it was back at pretty much where Jupiter is, around 500 million miles away. This week, it just crossed the orbit of the planet Mars, about 150 million miles away, and the tail is beginning to really develop. And this is where I showed you before. It's where the activity really begins to increase because it's getting close enough now to where the outer reaches of the sun's atmosphere, which it does extend far into space, is reaching the comet now. And it's beginning to activate the comet and some of the gases on it. Again, tonight, or today, at this particular time, the comet, and Dr. Wooten has got some excellent charts up there for both October as well as November. The comet is up near the sickle of Leo. This was probably October the 4th, maybe the 2nd, the crescent moon. Disregard that because we had to reschedule the talk, so this is not particularly accurate. But Mars is very close to the comet right now, and the comet is visible in small telescopes and in good binoculars if you know exactly where to look. What you will see in a pair of binoculars is a little tiny, looks like an out-of-focus star that's elongated, and the elongation is the tail. So it can be seen, but don't give up on it. It's going to get bigger, and it's going to get a lot brighter. This is through a telescope this morning in New Mexico. A friend of mine sent me this so that I could have it for the talk tonight. This is the actual comet photograph this morning before dawn. It's in the early morning sky. And so you see it's got a pretty nice tail. This is not a real big telescope, so this is very encouraging. What I call the lineation of the tail, where it's beginning to stretch out and not be so much like a tadpole, that is a really, really good sign. Because that shows that the outgassing of the comet is taking place very rapidly and is being pushed away as fast as it's being produced by the nucleus of the comet. So we've got this comet, developing. You see a little bit of a coma. Can't see the nucleus because the coma is so bright. But this is Comet ISON this morning, so you can see it's not a bad-looking object if you have a telescope. Now, in late November, the comet's going to get closest to the sun in November. As a matter of fact, most of the forecasts say that on November 28th, 29th, and 30th, the comet won't be seen because it's going to be too close to the sun to see. But if you go out at noon, and if the comet pans out the way that we're expecting it to do, or the way most people are expecting it to do, you may be able to go out and block the sun with your thumb and look up and actually see the comet with your naked eye. Now, I want to warn you, don't try to do this with binoculars. I mean, you're not going to block the sun out in a pair of binoculars. do it just with your eye and just see if you can see it. As this progresses and as time gets closer and closer, I'm sure that the college will put out information as far as where it will be in relation to the sun, which side of the sun to look, and whether or not it's even going to be visible in that way at all. But in late November, the comet's still going to be in the very early morning skies. As you can tell from this artist rendition here, and he left the cabin out on this one, the comet is going to be seen at twilight. Notice that the sky is not dark. It's not night anymore. The sun is becoming, it's dawn. And so this is just probably 45 minutes before sunrise. That's facing east again. So this is probably what you will see if things pan out. And this is, again, not through binoculars, not through a telescope. This is probably what you will see naked eye. Now keep in mind when I say this, you're looking at this and it is dawn, and we see some trees off in the distance here. That's a little exaggerated. You need a really, really good east horizon. You need to be able to see all, go down to where the water is and look over the water. That's the best way you're going to see it. It's going to be due east, not southeast, south, or northeast, but due east. And then on November 29th, this is the most active part of the comet's history right here. At this particular time, look at the speed the comet's going to be moving. Almost 1 million miles an hour. This is faster than any comet that we have actually been able to peg as far as a velocity. 870,000 miles an hour as it circles the sun. Remember the slingshot effect? That's what's happening here. It's beginning to accelerate because it's right next to the sun. You can see in my artist rendition, it's down here. The sun is right down here. And it's just pre-sunrise. The comet head, you can't even see it. It's rising behind the horizon. But look at that tail. And that is not actually a best case scenario. This is kind of a, let's be a little bit optimistic estimate right here. It could be even more spectacular than this. This is the last day that you will see it in the morning sky, which will be November 29th. You'll lose it on November 30th. You won't be able to see it. By December 26th, the comet has already gone around the sun. It's beginning to slow down. Notice the speed's dropped to 750,000 miles an hour. This turtle's pace. And look where it's going to be. It's going to be way out again, and it's going to be between the orbit of Mercury and Venus. But here's the Earth, and we're looking at it from a great distance away. You see, we're having to look across space quite a few miles. But it's going to be quite a nice comet. It will be smaller because we are looking at it on the other side of the sun. Now here's what we found out today, and this is really cool stuff. And this is facts. This is from Harvard Smithsonian. They ran a series of orbital tests on Doppler tests that they've been running on ISON since it came back out on July 4th from Hubble. And thus far, no one's really said, I'm going to tell you, we're snake bit. We're not going to tell you anything about this comet that's optimistic at all. So they haven't said much, but this morning was very, very encouraging. The comet, from what we're being told, has not been rotating at all. Remember I told you that comets begin to spin because of those two forces? This comet has not been spinning. I didn't know that until this morning. Normally we just assume comets are spinning. This comet has just been moving kind of like the moon moves around the Earth. It has sort of a locked rotation. This comet has not actually exposed any but one side to the sun this entire trip in. It's just now beginning to turn. And the release this morning is that the Doppler is beginning to show that this thing is beginning to spin and set up an orbital rotation. We're talking about that little 3-mile nucleus is beginning to spin like a top, which means that it's going to turn a volatile side to the sun. In other words, this is a side, one side's been facing the sun all the way in. Nobody knew that. This morning they're saying it's going to turn, and a fresh side is going to face toward the sun. And the hopes is that the heating from the sun, as well as any volatility that may still exist, it being a primordial fresh comet, there's probably pockets of exposed rare gases that will explode. And this idea that the comet's going to disintegrate, that's not what we're talking about. It's not going to explode into pieces. It's going to explode violently as an object. It's going to have outgassings and what you could call mini volcanic eruptions that are going to spew out gases and create quite a spectacle. So right now, the prognostication for this comet is actually very, very good. The idea that fresh material is fixing to spin sunward and it's going to be exposed to these hot gases is very good at this particular time. because in just 2 weeks, it's gonna really start heating up. It's getting close enough to the sun now, to where it's not just energy hitting it, but actual heat is beginning to have an influence on the comet. So that is good news. I think it's actually gonna turn out to be a good comet. Christmas Eve, you've heard people call this the Christmas comet, and that's pretty much what it's gonna be. This is a very pessimistic concept about what it would look like to the naked eye. Looking northwest, much farther to the north now, but look how much higher in the sky it is. It's in the western sky now, no longer in the east. So go out after sunset, about 45 minutes to an hour. The comet will be well up in the west, have a nice north-facing tail, and it's certainly visible to the naked eye. I think it's actually going to appear brighter than this to the naked eye. But once again, we really don't know. So it could be something spectacular like this, or it may be like Comet Kohoutek in 1973. But if it is like Comet Kohoutek in 1973, I want everyone to forget that you ever came to this lecture. Because I honestly believe, and I'm going to go out and live here and say it's going to be a very, very nice Christmas comet, and I hope that all of you enjoy it and share it with your friends. And I'll take a few questions, and then I'll let you come up and touch the, I'll tell you a little bit about the Campo del Cielo meteorite and why we think it probably is a comet particle, or possibly could be. Any questions?
Yes.
You're talking about Christmas Eve, Christmas Day. Is it going to last into the first of the year?
Absolutely, absolutely. It's going to get higher in the sky in the west and much more visible as far as the angle and the favorability as far as not having to have a low horizon. But at the same time, it's moving away from us. So expect it to get smaller and less bright. But then again, very much like Hale-Bopp comet, when Hale-Bopp came by, it was so active, it just hung around for months. For 2 months, we had a naked eye comet in the skies. So it could last a long time, but it will be getting ever so dimmer and ever so much further away and consequently smaller. So that's a good question. Yes, it will be visible easily into January. But yes.
Dr. Clay, the comet will be visible with NASA spacecraft in the days right around Thanksgiving, the SOHO and the SDO.
Yes.
So you'll be able to monitor it on the spaceweather.com site, but the keeper of spaceweather.com, the JPL scientist, Dr. Tony Phillips, a former student of mine, and I were talking about an intriguing possibility that those of you with solar filters, like the Botter solar filters, may be able to see it through your Botter filter on Thanksgiving, right up there, one solar radii off from the sun. If it develops as bright as it is, then you'll see the sun and the comet in the same low power field with the Botter solar filter. I'm not going to guarantee it's going to happen, but there have been comets that bright in history. Now, the Botter technology hasn't existed for 10 years.
But it would have to be brighter than the planet Venus.
It would have to be brighter than Venus. But remember, at one solar radii, that nucleus is going to be 3,000 degrees hot. That nucleus is going to be hotter than the red giant star Antares that you're going to be seeing outside in 15 minutes.
But it's only 3 miles across. So
yeah,
we really,
that's hot.
It's a very iffy thing, and you're absolutely right. If it can reach -8 magnitude, it should be visible through solar filters.
Yeah, so it's worth trying for.
Yeah.
Well, I'm going to set up some telescopes for
Sure.
us.
Thank you. Anyone else? Yes. I'm sorry. Please repeat.